In this video, I'll briefly go over each level available in the data folder of the content examples for my GameTools Blender extension. Each folder includes a source directory containing the blend file, the mesh and an XML report. The blend file is especially useful as it lets you inspect the exact bake settings and how the data baker tool was configured to achieve the demonstrated result. Alright, let's get started. Bitpacked Quat. This demonstrates targeting objects via a custom property to bake their rotation as a quaternion. That quaternion can then be spherically interpolated to create a target rotation to orient towards. Custom origin. This simply shows how to override Blender's world origin with a custom origin. Any data computed relative to the world origin, like a position, will now be relative to the custom origin instead. This can be useful for adjusting the baked object center point or similar tasks. Custom prop. This showcases baking the value stored in each object as a custom property directly into UVs. Pretty straightforward. Frame offset NOR, I already covered this one in a previous video. It demonstrates a concept similar to baking a shape key, except instead of using a shape key's vertex offset and normals, the data is computed from a target frame relative to the current frame. Great for storing multiple poses from an animation, among other use cases. Mask linear and mask spherical, both of these are straightforward examples of baking a mask. The linear mask is applied along each object's up axis from its origin, and the spherical mask works similarly. Parent XYZ pose, this one's particularly interesting. It showcases the source option for baking data from parent objects rather than, or in addition to, the object itself. In this example, each object's own pivot point is baked into UVs along with its parent's pivot point. Assuming the grandparent is centered at the static mesh's origin, its pivot can be inferred from the mesh's position. This enables reconstructing a hierarchy somewhat similar to Pivot Painter, as demonstrated in earlier videos on the Object Attributes Baker tool, though with less flexibility. Since this relies on vertex data, specifically UVs, it's more limited compared to storing data in textures. But with a bit of creativity, it's definitely usable. Round Gear Normal demonstrates generating a random unit direction and storing it in the normals. Round per call, this one generates a random value per collection and stores it in UVs. Round per face, similar to the previous one, but the random value is generated per face. Keep in mind that this duplicates all vertices. Round per object, still on the topic of random values, this example bakes a random value per object into UVs. Very simple. Shape key offset demonstrates baking the offset of a shape key. The base mesh is a cube that morphs into a deformed ball. Keep in mind that normals are not fixed when using world position offset, and they were not baked in this example, so they remain unchanged during the morph. This is addressed in the next example, shape key offset normal, where the morph target's normal is baked into vertex colors. Value, a simple scene used to test baking a fixed value into UVs, nothing fancy. XY pose NOR, an experimental test that bakes X and Y position into the normals. The Z component is discarded to be computed so the final vector remains normalized and preserves the X and Y values, if that makes sense. This was explained in a previous video and is also documented in the wiki. The next two examples, XY pose packed and XY pose packed NEM, showcase packing X and Y position using numeric and bitwise packing modes. This requires 32-bit UVs and was the main topic of the previous video, so I won't go into detail here. XYZ axis is a simple example of baking each object's forward axis into UVs. XYZ pose is a textbook example of storing XYZ position across 3 separate UV channels. Very basic. XYZ pose frac axis builds on the previous example by packing the axis into the fractional part of the position stored in each channel, also discussed in the previous video. The next two examples, XYZ pose packed and packed num, showcase packing the XYZ position using numeric and bitwise packing modes. Again, this requires 32-bit UVs and was covered in detail in the previous video. XYZ pose vcol demonstrates baking XYZ position into vertex color using remapping. XYZ pose XYZ axis. Finally, this example shows how multiple UV maps can be used to store data such as position and axis vectors. And that's pretty much it for the content examples related to the data baker. A very tiny glimpse into what's possible with this tool. The sky's the limit. Go nuts and have fun.